For this lesson, we want to talk about solving quadratic equations. Now, remember, when we have a quadratic equation, we have that form, I didn't want that, of ax squared plus bx plus c. And in this case, we're going to say it's equal to 0. Remember that a, b, and c have to be real numbers, and a, that leading coefficient, cannot equal 0. If a equals 0, then this whole term would be equal to 0, and we'd be left with a linear equation. We've already talked about how to solve linear equations, so we want to have an x squared in all of our quadratic equations. Now, to solve quadratic equations, we're going to use what's called the zero factor theorem, where 0 is the important part of it here. We say if m and n are real numbers, and if m times n equals 0, then we know that either m has to equal 0 or n has to equal 0. Think about that. If you know that two numbers are being multiplied and their product is 0, you know that one of the numbers has to be 0. So look at this example that we have here. We're asked to solve for x and use the zero factor theorem. We have here m times n equals 0. That means we know that each of these factors could equal 0. So we let m equal 0 and we let n equal 0, because one of them has to equal 0 in order for the product to be 0. Now we just have two linear equations that we know how to solve. Add 3 and divide by 2. And in this one, subtract 1. So we have two possible solutions. Now be careful when you're entering your answers in MathLab. It may give you x equals, and then you're asked to separate your answers with a comma, in which case you could write them in like this. Or it could give you a solution set, in which case you're just putting in the solutions that you found separated by a comma. So just read carefully, pay attention to which type of answer you're being asked to give. So let's talk about some steps for solving quadratic equations. And I want to be clear that right now we're solving quadratic equations by factoring. At the end of the semester, we'll look at some other methods for solving quadratic equations. But right now we want to continue practicing with our factoring, and we're going to use that to solve quadratic equations. Step 1 is really important. One side of your equation must equal 0. So if the equation doesn't equal 0, you cannot factor. Make sure it equals 0 before you start factoring. The second step is to factor completely. And I have to say that the most common error I see on final exams and tests is that people can't factor, and therefore they can't solve the equation. So make sure you go back to last week's lessons and practice all those different types of factoring. Next, we use the zero factor theorem. Oh, I see this time I wrote a times b instead of m times n, but it doesn't matter. If we have two factors, then one of them, a has to equal 0 or b has to equal 0. And then we just solve the equations that we're left with. So let's look at this first example here. X squared minus 3x minus 18 equals 0. Step 1, make sure one side is equal to 0. We have that. Step 2, factor completely. Now your factoring work should be rough paper work. I don't want to see all the work that you do for factoring. So let's down here at the bottom, let's take a look at this. We want two numbers that multiply to equal a times c, that's negative 18, or add to equal b. We can list our factors of a times c. We see that we're going to use the 3 and the 6. And because the 3 has to be negative, we know that we want 6 to be negative. So we have x squared minus 6x plus 3x minus 18. Now we're going to factor by grouping. X is common in the first group, plus 3 is common in the second group. We see that x minus 6 is common, leaving x plus 3. So all of this is rough work. I don't want to see this in your equation. When we go back to the equation now, we can just write our factored form, x minus 6 times x plus 3 equals 0. Step 3, use the zero factor theorem. A can equal 0 or B can equal 0. And then we just solve these linear equations. We see we have 2 solutions. X could be -3 or 6. Why don't you pause your video, use the steps I've given you to solve question 2. Step 1, the equation has to equal 0. So we've subtracted 20 from both sides. Step 2, now we can factor completely. So you've done your factoring work. Remember, I don't want to see all of the factoring work. That's for rough paper here. Now we can use the zero factor theorem. A equals 0 or B equals 0. We see that x equals -5 or +4. Oh, I should say something about this. You can always check your answers using substitution, just like we did for linear equations. If we check, let's say x equals -5, we would have -5 all squared plus -5, excuse me, equals 20. So -5 all squared is +25 minus 5 equals 20. Yes, we know we're correct. So when you're solving equations for a final exam or for a test, you should always know in advance whether you solved correctly. Solve, then check your answers. All right, let's get started on question 3 together, and then I'll let you finish it. Step 1, one side of the equation has to equal 0. Now, I always like my highest power of x to be positive. So I'm going to subtract 5x squared from both sides. I'm going to add 6x to both sides, and now it equals 0. Remember, we have all of those different methods for factoring, and the leading method I told you was to check for a greatest common factor. We see that x is common here. But we haven't factored completely because we don't know if we can factor this quadratic trinomial. Pause your video, finish this up. So you did your rough work for factoring below. Now, we don't just have A times B equals 0. We have A times B times C equals 0. But we know that if we're multiplying and the product is 0, one of our factors has to be 0. So we can say that A or in this case, x could be 0, or x minus 2 could be 0, or x minus 3 could be 0. So we see in this case, we have 3 possible solutions for x. X could be 0, or 2, or 3. So here's an interesting question. It's factored already. But we can't use this factoring. The first thing you do when you see a question like this is open the brackets and then let one side equal 0. Why don't you pause your video, give this question a try. So we said you should open the brackets first. Now let the one side equal 0. So I'm going to subtract 14. And then you factored. Do we need to do this one together? I feel like whenever the numbers are bigger, people have trouble. We have two numbers, a times c. What is that going to be? 30, 42. Two numbers that equal 42, negative 42. And add to equal -1. Well, I hope you know that's going to be 6 and -7. So we have to rewrite our equation. (3x) was common in the first two terms. -7 was common in the last two terms. So x plus 2 is common, leaving 3x minus 7. So we have x plus 2 times 3x minus 7 equals 0. Again, reminding you that all of that factoring work is rough work. I don't want to see it right now. Our first factor could equal 0, or our second factor could equal 0. So two possible solutions here. X could equal -2 or 7/3. I'm going to stop this video here. I want you to go do some practice before continuing with the next video.